Hey, welcome back, students. In this video, I want to go ahead and address how we find Q, or rather the heat of a reaction. So in chemistry, we use this equation generally to find out whether a reaction gives off energy or whether it gains energy. In this particular case, we're looking at whether it gains heat or whether it loses heat. So we have this sample problem here for us, and it reads as follows. A sample of water has a mass of 955.8 grams, and it undergoes a temperature change from 15.24 degrees Celsius to 88.96 degrees Celsius. What is the heat change of this sample in joules? Well, keep in mind that if we do this, we got to keep in mind what the overall equation is going to be. That equation is going to be the following. I'm going to go ahead and write this at the very top here. We're looking for Q being equal to the mass of the sample times the specific heat of the sample times the delta T, which is going to be the change in temperature. So that's the equation we're going to use. And let's go ahead and identify in this sample problem all the parts that are going to give us clues as to how we solve this. Usually I always begin by looking at the numbers and underlining all of the numbers. So we've got a 955.8 grams there, we've got an 88.96 and a 15.24 there. Once I've underlined them, the next thing I want to do is go ahead and look at the question. The question here is, what is the heat change? So heat change here is generally referring to Q, so we're going to be looking for Q because we don't know what that is. And so if we look at all the other numbers here, the 955.8 grams, this here is denoting the mass. If I look at the 15.24, this is a temperature value, and since it's the first temperature value that's given to us, this is our initial value for temperature. And then the 88.96, this is another temperature value, and this is going to be our temperature final, because that's the final temperature that's given for the system. So what we need to do is go ahead and solve for Q. In this case, the equation is already written out for us all the way, so all we need to do is take this equation and substitute all the values. So we'll go ahead and do that now. So Q is equal to the mass. In this case, the mass is 955.8 grams. And we're going to multiply this by the specific heat of water. Now, given that a lot of this information for specific heat is going to be given to you either within the problem itself, or it will be provided to you in a table that's provided within the problem itself. And so in this particular case, I'm going to go ahead and provide that for you. The specific heat of water, liquid, is going to be 4.18. And so 4.18. And the units here are going to be joules per gram Kelvin. And we're going to multiply this value by the change in temperature. Well, the change in temperature here is going to be the final temperature minus the initial. And so what we need to do here is write it down as 88.96 degrees Celsius minus the 15.24 degrees Celsius. Now, we could leave it like this. However, we're not really going to be completely satisfied because what we need to do is convert this to Kelvin. And so we need to change each of these numbers here for Celsius into Kelvin first before we can actually do that. So let me go ahead and take care of that for us right now. And so what I will do is I'm going to go ahead and erase this section here. And I'm going to go ahead and replace these with the actual Kelvin values. And so here we'll have, for the 88.96, which is our final temperature, we add 273 to that, and that'll give us 361.96, and this is going to be Kelvin, minus the temperature for 15.24, and all we're going to do is add 273 to that, and that'll give us a value of 288.2 for, again, this is in Kelvin. So I need to go ahead and simplify this, and so I'll just go ahead and rewrite this. Keep in mind that my Q value is going to be equal to 955.8 grams, which I will then multiply by 4.18 joules gram Kelvin. And now I'm going to simplify this temperature that I've got here. So I'm going to take my 361.96, subtract it from 288.24, or subtract 288.24 from the 361.96. That'll give me a value here of 73.72. And this is going to be in Kelvin. Now what I need to do is go ahead and multiply all of these numbers. So I'm going to take 955.8, I'm going to multiply that by 4.18, and then multiply that answer by 73.72. And what I wind up getting here is a Q value equal to 294,529.38. And the units here are going to be the following. Since my grams cancel with grams and my kelvins cancel with kelvins, the units that I'm looking for is in joules. And so this here is my answer in joules. Now notice how the number is pretty big, so you could be asked to convert this to a kilojoules, in which case all you need to do is divide this number by 1,000, and that would be equal to the same thing over here, 294.5 kilojoules. So both of these are correct answers here. One is in joules, the other one is in kilojoules. So hopefully that helps you understand how to find the heat of a reaction.